Hello guys, welcome to the Doubtlet. In this video solution, we will discuss the operations on complex numbers. First of all, we will learn what are complex numbers and then various operations that are withheld with the complex number system. So we know that you have heard about the real number system. So real numbers are the numbers which can be plotted on the number line. Means from minus infinite to infinite, there are various numbers which can be rational, irrational, negative, positive, all type of numbers. It may be integer, fraction, natural numbers, whole numbers. So all these numbers which can be represented on number line are known as real numbers. And apart from this, there are certain numbers which are left out. All those numbers are known as complex numbers, and these are also called as imaginary numbers. Imaginary number in a sense that these cannot be represented on number line. So we cannot represent the complex numbers on number line. So how we will differentiate? So suppose we can write a number that is 3. So this is a real number. And if I will write an example of 1 plus 2 iota, so this is an example of complex number. So this 1 plus 2 iota cannot be represented or cannot be plotted on the number line. Now, since these are also numbers as real numbers, then definitely we can apply some operations, means some mathematical operations on these type of number system like addition, subtraction, multiplication, division, and apart from these we can also find the inverse, modulus, conjugate, and various other operations. So first of all, I want to tell you that we can represent these type of numbers on a argand plane. So suppose this is argand plane and this is the real axis, means this is the axis on which the real numbers are plotted, and this is the axis, means the y-axis on which the imaginary numbers are plotted. So suppose there is a complex number z and it can be represented as x plus iota y. So if we will draw a line from origin to this point, so the coordinates of this point should be x comma y. So this is how we represent a number line on argand plane or a rectangular system. And we know that if this line makes an angle theta measured anti-clockwise from the positive direction of real part, then this angle is known as argument of z, argument of complex number. So this all we will discuss in the next slide. So first of all, let's take the example. Let's suppose this is z. Z means complex number and it can be represented as x plus iota y. So we know that if we will take a another number x1 plus iota y1 and another number that is x2 plus iota y2. So first of all, we will just know all the terms of this complex number. So this is x. So we will call this x part as real part of z. Real part means this part contain the real part of complex number. And whatever be the coefficient of y, we will call it as coefficient of iota. So this is iota. And this is the representation symbol. And the mathematical meaning of this iota is under root of minus 1. So we always write this under root of minus 1 as iota. So the coefficient of iota is the imaginary part of the real number. And this is iota that we have discussed here. So first operation about the complex number we will discuss, that is addition or subtraction. So suppose we need to add these two complex numbers z1 plus z2 that are given here. So to add two complex number, we have to add the real number simultaneously and the imaginary part simultaneously. So the real part is x1 and x2. So we will add this x1 and x2 together. So this will become another real part of this complex number. And then we will take the iota and we will add the coefficient of iota simultaneously. This is y1 plus y2. So this is how addition is performed. Similarly, if we need to subtract from z1 from z2 from z1. So what we will do? We will again follow the same rule of just considering a real part first and then imaginary part first simultaneously. Then we can write this as x1 minus x2. So this is the real part, and iota coefficients are y1 minus y2. So this is how addition and subtraction are performed on complex number system. So we can take a real example. So suppose z1 is 2 plus 3 iota and z2 is 5 minus 6 iota. So if we will need to add these numbers, then we will add the real part. So 2 plus 5, it will become 7, and plus we need to add the imaginary part 3 plus minus 6. So it will become minus 3 iota. So we can write this as 7 minus 3 iota. So this is the addition of z1 plus z2. And similarly, we can perform subtraction also. But in subtraction, you have to take care of the negative symbol. The second operation, we know that in arithmetic we study multiplication. So here the multiplication is performed in somewhat different way. So let's suppose z1 is a plus iota b and z2 is c plus iota d. This is c plus iota d. So if we will need to multiply z1 with z2, then we can write this as a plus iota b multiply by c plus iota d. So we need to multiply this as the polynomial expressions. So first what we need to do, we need to multiply c with a, then we need to multiply c with iota b. Then what we will do, we will just multiply this whole term by this and then by this, and we need to add each terms. So first c will be multiplied to a, then it will become ac, and then c will be multiplied to iota b, this will become iota bc, then plus this iota d will be multiplied to a, so it will become iota ad, and this iota d will be multiplied to iota b, this will become iota square bd. Now the one thing you need to remember, that is iota square is always minus 1. And how we have got this? We know that we have written iota as under root of minus 1, and if we will square this, then what we will get? We will get minus 1. And if we will just need to find iota cube, then we can write this as iota square into iota. So iota square value is minus 1 and iota is iota. So iota cube is minus iota. And now supposedly we need to find iota ki power 4, iota to the power 4. Then we can again write this as iota square into iota square. So minus 1 multiplied by minus 1. So we can write iota to the power 4 as 1. It means every fourth power of this iota, we can just convert that to 1. Suppose you need to find iota to the power 96. So we can write this as iota to the power 4 to the power 24. So this quantity is 1. So 1 to the power 24 is 1. So this is how we can calculate the power of iota. So I hope you got this till now. Now we will focus on the multiplication. So from here we know that iota square is minus 1. So we can, if we will solve this, what we will get? AC. Then if we will take the iota common from second and third term, what we will get? BC plus AD. And this iota square is minus 1. So we can write this as minus D. So we know that if we will multiply A plus iota B and C plus iota D, we will get AC minus BD plus iota times this is BC plus AD. So this is the multiplication that we have got when we have multiplied this Z1 with Z2. Now we will take a real example. Here we have considered the variables a, b, c, d. Now we will take the real example like 2 plus 3 iota, and z2 is 5 plus 3, 5 plus, so we can consider minus here. So 5 minus 2 iota. So we need to multiply these two complex numbers. So we will just start from here, 2 plus 3 iota and 5 minus 2 iota. Correct? Then we will just follow the same principle, that 5 multiplied to 2, then 5 multiplied to 3 iota. So 5 multiplied to 2 is 10, and then this will become 15 iota. Then we will just consider this 2 iota term, and we will multiply it by 2 and then by 3 iota. So 2 iota will be multiplied to 2, this will become 4 iota, and 2 iota, sorry, this is minus 2 iota. So here it will become minus 4 iota, and this will become 6 iota square, minus times of 6 iota square. And in the previous slide, what we have learned, that iota square is minus 1. And then if we will replace this iota square with minus 1, then this will become plus 6. So we can write this here, 10 plus, this will become 11 iota, because 15 iota minus 4 iota is 11 iota. Because the imaginary parts can be subtracted and the real parts can be added and subtracted. So this will become 6. So the multiplication of this is 16 plus 11 iota. So this is how we have multiplied two complex numbers. So if you will practice more, then you will learn. It is an easy thing. So now we will focus on the third operation, that is division. So division is the just like inverse of an multiplication. Like suppose we need to divide z1 by z2. So we can write this as a plus iota b divided by c plus iota t. Now we cannot break this like in the polynomial system. So what we need to do, we need to multiply c minus iota t, which is the conjugate. And now here we need to learn about the conjugate first. Means conjugate. What is a conjugate for a complex number system? So conjugate is basically represented by z bar. And if z is represented, so suppose let's z is a plus iota b, then conjugate z bar will be always represented by a minus iota b. In conjugate, what we will do, we will change the sign of imaginary part. So suppose z is 2 plus 3 iota. So here the imaginary part is this 3 plus 3. So we will change the sign. So to find the z bar, means conjugate of z, we can write this as 2 minus 3 iota. Let's suppose there is minus 1 minus 5 iota. This is z, and we need to find the z bar. So z bar, how we will write? We will change the sign of the coefficient of iota. Means this is the imaginary part. So the real part will remain as it is, and we will change the coefficient sign of the coefficient of iota. So this will become minus 1 plus 5 iota. So while performing the division operation, we will multiply the denominator, conjugate and divide it. Means if we need to, so suppose this is the operation that we have to find. So what we need to do, we need to multiply by the conjugate and divide. So this can be cancelled out. So this will have no effect on this complex number. So that's why to make the process easy, we will multiply and divide by the conjugate. So the conjugate of c plus iota d means conjugate of z2. We can write this as conjugate of z2. So it will become c minus iota t. So c minus iota d will be multiplied and it will be divided. And now we know that this a plus iota v will be multiplied to c minus iota d, and c plus iota d will be multiplied to c minus iota d. So we will multiply the numerator complex number separately and denominator separately. So first we will multiply the numerators a plus iota b and c minus iota d. So if we will again just follow the same principle, so this will become ac, and then it will become iota bc, this will become minus iota ad, and this will become minus iota square BD. So definitely what we have got AC plus BD, because iota square is -1, so this will become plus. So this is the real part of numerator. Plus, if we will take iota common, so this is iota, this is BC minus AD. So this is the numerator. So we can write this as numerator. Now we will solve denominator. So for denominator, we know that this is C plus iota D multiplied by C minus iota D. So if we will multiply this, this will become C square. This will become iota CD minus again iota CD, and this will become minus times of iota square and D square. So iota square is -1, so it will become plus. So we can write this as C square plus D square, because these two terms are, this is iota plus, so these two terms will be cancelled out. So the denominator is C square plus D square. Now we will divide this by numerator. So numerator that we have got it here, and this is denominator. So we can write this as AC plus BD plus iota times of BC minus AD divided by C square plus D square. Now we know that from the principle of, like, if we have a polynomial in the form of P plus Q divided by R, so we can write this as P divided by R plus Q divided by R. So here P is this term, Q is this term, and R is this term. So we can easily write the real number as AC plus BD divided by C square plus D square plus this is iota. So again we can write this as BC minus AD divided by C square plus D square. So this is the real part and this is the imaginary part of complex number Z1 divided by Z2. So because this is also a complex number, so we have written it in the form of real and imaginary part. So this is how we have performed the division process on complex number system. Now we will take the real examples. Let's suppose Z1 is 5 plus 6 iota and Z2 is -2 minus 3 iota. And we need to divide these two numbers. 5 plus 6 iota divided by -2 minus 3 iota means we need to find Z1 divided by Z2. So what we have learned, we will multiply the conjugate of Z2 and divide. So conjugate of Z2 will be -2 plus 3 iota divided by -2 plus 3 iota. Correct? Now we will multiply 5 plus 6 iota by -2 plus 3 iota and -2 plus 3 iota by -2 plus 3 iota. So first we will just multiply the numerators. This is 5 plus 6 iota multiply by -2 plus 3 iota. So we will multiply this 5 by this and then by this. So this will become -10, this will become -12 iota. Then we will multiply this whole term by 5. So this will become 15 iota. And this whole term again with 6 iota. So it will become 18 iota square. Iota square is -1. So this will become -10. This, if we will add these terms, so it will become 3 iota. And this will become -18. So we can write this as -28 plus 3 iota. Correct? Now just considering the denominators. So -2 minus 3 iota and -2 plus 3 iota. So again this -2 will be multiplied to this and then by this. So it will become 4. This will become 6 iota. Then we will multiply this 3 iota by -2. This will again become -6 iota and then by this. So it will become -9 iota square. So we know that 6 iota will be cancelled to -6 iota and this will become 9. So the whole value will become 13. So if we will find Z1 divided by Z2, then what we will get? we will get minus 28 plus 3 iota, and this is 13. So if we will just solve out, so this will become minus 28 divided by 13, this will become 3 divided by 13 and iota. So here this is the real part and this is the imaginary part. So I hope you got the concept that how to divide two complex numbers. So till now we have discussed the addition, subtraction, multiplication and division. Now we will learn how to find the inverse. This is the fourth operation. So inverse means, suppose a complex number z is given and we need to find the inverse, means 1 upon z. So we know that let z is equal to a plus iota b and we need to find 1 upon z. So what we can write here, 1 upon a plus iota b. But we need to find this number in the form of complex number, mean in the form of real part plus imaginary part. Here it is not in that form. So we will again just follow the same principle as we have followed in the division part, means we will multiply it by its conjugate. So it will become a minus iota b and then a minus iota b. Means if you need to find 1 upon z, then multiply it and divide by the conjugate of denominator. Then you will find the number in the complex number form. Correct? So if we will multiply 1, means, so 1 can be written as 1 plus 0 iota. 1 is the real number, but we can also represent it in the form of complex number by this method, 1 plus 0 iota. So if we will multiply numerators, we will write 1 plus 0 iota will be multiplied to a minus iota b. So it will be a minus iota b itself, because whatever will be multiplied to 1, it will just become itself. So a plus iota b multiplied to a minus iota b. So if we will multiply this, we will get a square plus b square. And now if we will find 1 upon z in complex number form, so we will get a minus iota b divided by a square plus b square. And now we can separate these, a divided by a square plus b square plus iota, this is minus b divided by a square plus b square. So this is again the real part and this is again the imaginary part of a complex number. So we can write this complex number as Z3 because this is also a complex number. So this is how we have discussed the inverse operation on a complex number. Now the next operation will be how to find the modulus, and I will also tell you the geometric interpretation of complex number. So suppose there is a complex number that is a plus iota b that is given, and we need to find the modulus. So modulus is represented by z or modulus of z. So to need to find this, what we need to find the formula, we need to follow the formula, that is we need to square the real part and then imaginary part square, and we need to take the square root of this. So this is the formula to find the modulus of a complex number. So here we know that real part of z is a, means this is the real part, and the imaginary part of z is b because the coefficient of iota is b here. And to find the modulus, means mod z, what we need to do, we need to square the real part and then square the imaginary part, and we will take the square root of this whole term. So this in geometry it is known as the length of the vector, because suppose this is a complex number and it is represented by this line. So this coordinates are a comma b. So let's suppose the length of this is L or mod z. So the length of this from origin to this point P, and this is the complex number. So this is the representation of length of the complex number vector. So this is how we have found the modulus. So let's suppose an example in the real life, that is 2 plus 3 iota. So this is 2 plus 3 iota. So to find the modulus, what we will get? We will do that is 2 square plus 3 square. So if we will solve this, what we will get? This is under root of 13. Let's suppose there is another example, that is z is equal to minus 1 minus 3 iota. So if we need to find the modulus, what we will do? We will do the square of real part of this z, that is minus 1. So first we will write the real part. Real part is minus 1 and then imaginary part of z is minus 3. So again we need to square the minus 3 also, and we will take the square root. So this will become under root of 10. So the modulus of this complex number is under root 10. It means the length from the origin to this complex number vector is under root 10. So this is how we have discussed the modulus. This is the fifth operation on any complex number system. So we have discussed some of the operations like addition and subtraction. Then we had studied multiplication. Then we had studied division. Then we had studied how to find the modulus of a complex number. We had studied how to find the inverse of a complex number. We also know how to find the real part of a complex number and imaginary part of a complex number. So these operations, and conjugate also. Conjugate. So these operations we have studied, and in next video I will tell you how to find the polar form of a complex number, and then we will learn how to find the argument and the roots of the complex number. So this is the most complex topic. So I have to mark this as a star. So in the next video we will discuss all these three topics thoroughly. So I hope you like the concept that I have delivered in this video, and I have also made the calculator for each operations on my website, of which the link of which I will give you in the description box below. So you can also visit those blog posts and you can learn the step-by-step. You can learn with the step-by-step method. And please do share my YouTube channel to your friends so that they can also learn from these videos. Thank you very much. So I hope you got the concept what I am trying to deliver. So if you like this video, please hit the like button below, comment on this video, give the feedback so that we can improve upon the quality and the content of the solutions and the questions that we are providing. And please share it with your friends so that they can also learn the basic concepts and give proper feedback. And in the end, if you want to ask any other doubt, then visit my website. That is, link is given below in the description. And you can also ask your doubt by posting them in the comment box below. Thank you very much.